Hello ctrlX fans, welcome to this demonstration of the control-based touch probe functionality, which enables you to capture any axis position in the ctrlX Motion app with an accuracy of ±1 microsecond to feed into your registration process. For more background and details on how to set this up, please check out this how-to in the ctrlX automation community. You can find the link below this video. Let's start with the setup in Motion. I have an axis 2 that's synchronized to V master in position synchronization. So that's using MB gear in position, absolute synchronization with a 1-to-1 electronic gear ratio. V master is a virtual axis, meaning it has no drive connected to it, whereas axis 2 is connected to a ctrlX drive via profile 2. Let's look at the drive configuration in ctrlX Drive Engineering. If we go to Local I/O, XG31 pins 1 and 2 have their default mapping, which is to probe inputs 1 and 2. And I have a push button that supplies 24 volts to pins 1 and 2 simultaneously when the button is pressed. So this makes it easy to compare the results of different configuration settings in probe 1 versus probe 2. Press the button here a couple times to verify that the inputs are coming on. This is the function block I created to write the probe configuration to the data layer. You can see the available enumerations here for the signal that you want to capture. I'm going to configure probe 1 to capture actual position of axis 2 and probe 2 to capture encoder 1 of axis 2. Execute the configuration. And that gets written to this location in the data layer. So there's the probe 1 configuration. And there's the probe 2 configuration. Now we have to enable the probe function. When this is first enabled, the configuration here in the data layer gets written to the corresponding probe inputs on the drive. So we can see that, well, let's look at probe 2 first. So probe 2 is set up to capture S51, encoder actual position, continuous measurement, positive edge. Probe 1, which is set up for actual position, is going to capture system time fine, which is a fine resolution timestamp in the drive. And it's going to use this timestamp to calculate position. So I'm comparing these two methods, one where we're capturing the position directly in the drive, and the other where we're capturing the timestamp in the drive, and the probe function in the control will derive position based on the time at which the positive edge occurred. In my watch window, I have the speed of the master, the probe 1 captured position, the probe 2 captured position, and the difference between the two. So currently we're running at 100 RPM. and I'm going to press the button that's wired into the probe inputs. The registration data appears in this probe value structure. So if we look at the details of this function block and expand probe value, here we can see the counts. This increments every time the probe input is activated. And then this is the value that was captured. And depending on which probe features you enable, then you may see data in these other variables as well. So you can see the positions are very close to each other. Virtually identical. Now let's go up to 500 RPM. And we'll trigger the probe again. And again, we see positions that are very close to each other. Let's go up to 1000 RPM. Keep in mind, the timestamp is latched with an accuracy of ±1 microsecond. The delay of one EtherCAT cycle for the latched timestamp to be processed by the control is compensated for automatically using dead time compensation. Therefore, the accuracy of the captured position does not depend on the EtherCAT or PLC cycle time, assuming constant velocity. So this demonstrates that the results between the two capture methods are virtually identical, and either could be used successfully for a registration process. When I first tested this, I did see a small difference between probe 1 and probe 2 that was proportional to speed, but it was very consistent. And if it's proportional to speed and it's consistent, then we can solve it with dead time compensation. And that's why I put 102 microseconds of dead time compensation. The units here are nanoseconds, so 102,000 nanoseconds is 102 microseconds. I found that's what I needed to keep the probe 1 and probe 2 positions in alignment through the speed range. So that value gets written here in the data layer and then is written here in the drive. Now I'm going to show an advanced feature of the probe function, which is to capture not the slave position, but the master position that the slave axis is following. So I'm going to disable the probe. The probe is disabled by executing this AXS probe abort EX. And I'm going to change this to motion internal data. And I'm going to change this signal select extended to master axis position. So this input here is only relevant if I've selected motion internal data for signal select. And we'll execute the configuration again. Enable the probe again. Press the button. The scaling here is modulo 360. So 360 degrees difference is equivalent to 0. And initially I'm not seeing much difference here because the slave is in absolute one-to-one synchronization with the master. So they're essentially at the same place at the same time. But now let's introduce a phase offset. So let's have a look here at the master and slave positions in a trace. Right now you can see that they're right on top of each other. I'm going to add a slave phase offset of 90 degrees. So now we can see that the slave position is leading the master position by 90 degrees. And if we trigger the probe again, now we see that 90 degrees phase offset reflected in probe 1 versus probe 2, because probe 1 is now capturing the master, which is V master, that axis 2 is following, whereas probe 2 is capturing the encoder position. So this gives us the ability with our registration process to tap into the master position, which may be necessary depending on how registration is set up and where the registration correction is being applied. So that's a brief look at the new control-based touch probe functionality. Join the ctrlX automation community to find more information and use the forum to post your questions about touch probe and other topics. Thank you for watching.